Welcome to the ICND2 Cram guide. This is the second of the two guides I've split for the CCNA in case you want to take the 2 exam route instead of the 1 exam. Plus each one's over 60 or so slides, so just makes it easier to split it up. So if you want to get the updates, there's a couple of ways. I guess the easiest is if you come to howtonetwork.com. There's a free training link here which has got loads of videos, actually, webinars I've run for various things, and some PDFs. So you can put your email address in a little box on that page and I'll email you when there's other updates. I also do some exam study tips and motivational stuff and news about the industry. If you rather watch the YouTube videos or both, you can hit the subscribe button. And also this doesn't really seem to work very well anymore because of changes to YouTube's algorithm. So you can hit a bell and then you'll get a notification when I've uploaded a new video. I try and do one every 2 or 3 days, including crams and exam techniques and tips. So there you go. If you've never heard of me, and I'm sure many of you haven't, I've written quite a few books that are available on Amazon for Cisco, which these are all Cisco stuff. IP subnetting, which is vendor neutral. You can see obviously Cisco here, and then a CompTIA. Got other books coming out under my 101labs.net. You can see the URL there. Brand, which is pretty new for 2019. Used to work at Cisco TAC. I actually started my own IT company back in 2002, and as you can see I've written a few books, and I started knowing nothing, which I'm sure many of you are in the same boat at the moment. So I've already mentioned howtonetwork.com is one of my main sites. 101labs.net is a hands-on training site for IT, again, skills and exams, and in60days.com is for the Cisco CCNA program. So let's start with the first item that's on the syllabus for ICND2, which is the spanning tree protocol. It runs by default on all switches on your network. You can actually disable it, which would be an absolutely terrible idea. It's like would be like taking brakes off your car. You can do it, but that's not A. So it's maintained it runs, but it's actually maintained by one switch in the network. This is known usually as the root bridge. Different vendors may have different terminology, but we'll refer to it as our root bridge or switch, and it's obviously the root of the spanning tree network. It may not physically be in the center of your network. Basically, it selects blocking and forwarding ports. So some ports will forward traffic, others will block. And what this basically does is prevents a loop. This is actually a diagram for one of my books, but when the packet is received, the switch will record the port that this particular MAC address is on, and it sends out advertisements. But if you don't have spanning tree on, then every single switch will be advertising that it knows how to get to this device, and will have a loop, which we don't want. On a root bridge, all ports will be in forwarding state, so you'll get caught in the exam. They'll try and catch you out, but all the ports will be forwarding traffic on your root bridge, not on the non-root bridges. The port of the other switch is directly connected, so these ports directly connected, say this is the root here, switch A, these will be forwarding and known as root ports. They're pointing towards the root bridge. If they're pointing away, there'll be a designated port, or they'll be blocking. The selection of the root bridge is based on 2 main criteria, which is the lowest priority. Now, by default, this is the same on all switches. You'll hear bridges used as well. You can use them interchangeably in terms of STP. So they all have this priority, which can be changed. Then after that is the lowest MAC ID of the switch. So if these are your MAC addresses here, it looks like they're all the same: 1, 2, 3, 4, 5, 6, 7, 8, 9. All the 2s, all the 1s, and all the 3s. So by default, if they're all got the same a priority, which they will have unless you've changed it, then the winner would be the one with the lowest MAC address, which will be the root. And as I said before, these will be forwarding the all the ports. Now, STP worked well, but eventually there was enhancements introduced which are included in the syllabus. Etherchannel, portfast, BPDU guard, and rapid spanning tree. You need to know about all of these. RSTP, rapid spanning tree, it's an IEEE standard, so 802.1W if you get asked in the exam to tick which one it is. STP originally converged in about 50 seconds, which was fine maybe back in the 80s when there's probably just one or two main computers. Nowadays it would be catastrophic. So rapid spanning tree, it's actually milliseconds, but the documentation says it could be 2 seconds or less. The port states you'll need to know include root port designated, backup, and alternate or disabled, and you'll need to know which each of them does, which you can read up more in your textbook or videos. Per VLAN spanning tree Plus works with rapid spanning tree in order to allow an individual spanning tree instance per VLAN. So what can happen is you've got this busy network running. What you could do is say for VLAN 100 you will be the root, and for VLAN 200 you will be the root. So this is basically, depending on your traffic loads, it spreads your load on your network, which is a good idea. And then this one could be the backup for 200, and this one could be the backup for VLAN 100. So you'll always have connectivity, and you're spreading your load. This will come down to your design. To configure RSTP, you need to know this command: spanning-tree mode rapid PVST. Etherchannel, just check the config there, and you'll have different options depending on your iOS, different amounts of channel groups you can configure. However, you'll create your range of interfaces. You could do this individually if you so wish, but hopefully the range command will work on your device. Switch port mode access, and then channel group, you're given a number between 1 and 6. Again, it could be different on your platform. And then channel group, channel-group 1, mode, and these are your possible options. You'll need to read your documentation again, but make sure you know which modes are going to work for PAGP and which are going to work for LACP. The reason is in the exam they'll say what mode is working when you have passive for Etherchannel, and it's going to give you the options of PAGP or LACP, and you'll need to know. Just a simple command just to answer in the exam. So your physical ports are actually grouped into a logical interface, which is your channel interface. It could be one or more than one, obviously 2, 3, 4, 5, 6. Traffic is load balanced, but the config must match on both sides. So whatever you've configured over here will need to match over here. First hop redundancy protocols, or routing protocols, sorry. These provide protection from default gateway failover by providing backup routers. So the IP address and the default gateway here goes to this particular router is active. If there's a problem and this goes down, then the first hop redundancy protocol should be able to send traffic to an alternative or backup gateway. Also can provide load balancing and obviously network redundancy. 3 mentioned in the syllabus are HSRP, VRRP, GLBP. HSRP, you just need to know a few things about it. Cisco proprietary, which they'll ask you. It uses UDP, and here's the port number. Hello packets are multicast on 224002. Here are your intervals. There's a priority, i.e. which is going to be the active and standby. By default, all priorities are 100, which you can alter. It supports tracking an interface, which is mentioned. I think I mentioned it in my books, but I'm not sure if it's in the syllabuses. Sorry, you'll have to check that. But it can track interfaces going up, down, and load on the interfaces and then take action. Your states are active or standby. So these are the names of the master router and the backup router. Here's your configuration. For example, interface VLAN 100, IP address. Your standby IP is whatever you've decided to be the standby IP. I've changed the priority now to be 150, so this is going to be the master. Oh, sorry, looks like this is the master. This is 200, so this won't be the master. This will be the master and then the backup here. Standby IP was going to be the same, the 100.1. Preemption basically polls to see if this router is up or not, and then it can take over as the master. VRRP, similar function as HSRP. It's a virtual router representing a group of router, and the terminology is VRRP group. It uses the physical interface with a virtual interface IP address. Your group range numbers, check when you hit the question mark if you configure this, will be from 0 to 255. Now this uses IP protocol 445. And here are your timers, so make sure you take a note of the timers and compare it to the other standby protocols. Now here's a virtual MAC address. You'll see this MAC address, and in the exam they could ask you a question. They'll have a value in here, and remember this is a hex value, so don't get caught out if it's not a decimal value. So 11 doesn't equal 11 in hex. Your configuration looks pretty similar, but you've obviously got the VRRP here. We're tracking group 1 here. Configuration, there's a difference here. This priority is 120, this is 150. I've got authentication on here. I don't think that's covered in the syllabus actually. Then finally GLBP, similar to HSRP and VRRP, provides load balancing, which is a limitation in HSRP and VRRP. This uses UDP and it's port 3222. Here are your timers. Now this has a concept of the actual active virtual gateway. So if you get asked in the exam what does AVG use or what is it in reference to, it'll be Gateway Load Balancing Protocol. So the active virtual gateway answers ART requests for any virtual IP address, and it will serve the active gateway details. Here are your load balancing algorithms used by GLBP, weighted, round robin and host dependent. Not sure they'll ask you any more information than what I've just given you. Here's the configuration if you want to pause the video for a moment. Obviously it's well worth labbing all of these things up, which we cover in 101labs.net, and any of my Cisco books got labs in. Switch stacking is came into the latest version of the CCNA exam syllabus. What it does, you've got these physical switches and it groups it into one logical switch. So as far as the network sees, is one logical switch here and not 4 physical. There's a special cable which I'm sure they won't ask you about, but it's used to connect the switches for a special interface. Out of all of the switches, a stack master is elected, which you can affect if you want to choose specifically one switch to be the master. And if you lose one of these switches, it doesn't affect the rest of the stack. The stack actually stays open. One of the advantages is increased port capacity, because it aggravates the capacity of the ports. You'll probably, if anything, get asked some of the options, like what does FlexStack offer? Well, it's 4 2960 switches, plus gives you 8. Stack-wise is up to 9, but this is a higher model. This is the 3750 range, and probably higher models also. This is a new topic as well, 802.1x. It's IEEE standard. It gives you port-based network access control. Users are authenticated before they access network resources. You've got port level policy enforcement. Users can be placed into a predetermined VLAN, granting them network rights. So whatever their credentials are, they could be put into VLAN 100, 200, or whatever. And these VLANs will each have certain rights associated with them. The three questions, or one of the things that could be asked, is what are the devices involved in 802.1x? The three are the supplicant, the authenticator, and then the authentication server. And obviously you can see the request goes through the switch and then is permitted or denied, and the response sent back through the authenticator. Snooping is another new topic. It comes under the umbrella of security. It provides protection from rogue DHCP servers. It creates a logical firewall between untrusted hosts and DHCP servers. This could actually be a PC. It doesn't have to be a server. They've downloaded an email or gone to some website, got a virus which is on their device, and what it's trying to do now is take over the DHCP role on the network. But because the DHCP snooping has by default blocked this port here, then this won't actually happen. You've probably got notifications coming through to your security team or to you to warn you that packets have been sent onto this interface using DHCP, and then you can take action. This will be approved while you're doing your configurations, because you know, being the administrator, your DHCP server is on this interface. The DHCP snooping table is built on the device. I mentioned the interfaces. They're actually referred to as trusted and untrusted. VPNs again is another new topic. They've kind of asked you what it is, but maybe a bit more detail now. This is encrypted network transported over the public network, ideally for use when a company is using a service such as broadband. VPNs carry private data over the public network. They use advanced encryption and tunneling methods. You could be asked like a multiple choice, what does your VPN give you? Privacy, authentication, data integrity. The data packet is encrypted and encapsulated, and it's got a new header which provides your security. It can be configured for point-to-point network, point-to-multipoint, or for home-based remote access. And this will be your person working from home basically, but needs to access network resources. Your tunneling protocol, few choices here. Layer 2 tunneling protocol doesn't provide encryption, by the way. It's a combination of L2F and PPTP. GRE is an exam topic now. Does not provide encryption. It encapsulates IP and these non-IP protocols inside a packet before the packet's forwarded. IPsec, I'm sure you've heard of. It provides encryption, supports unicast and data integrity. L2F I've mentioned up here. It doesn't provide encryption. It was designed for point-to-point network traffic, but you could be asked which of these provides encryption and which doesn't. This obviously does here, and you can read the others. And then point-to-point tunneling protocol. It relies on a point-to-point protocol to implement security functionality. It uses control channel over TCP and a GRE, and it encapsulates PPP packets. GRE I mentioned. It encapsulates a number of network protocols over a point-to-point link. So what you've got is packets of another protocol inside this packet here, and this is referred to as tunneling, and there'll be a part of the packet here that will be used. So I've done a show run. I've got my IP address on my interface. I've created a tunnel interface, so you could interface T0 or tunnel 0. Added my IP address, and you must specify your tunnel source and your tunnel destination. This is the quickest way to make a mistake. My tunnel source, I've specified an actual interface name. The destination, not necessarily you will be able to use that because it's going over an IP network, so you're going to need to put an IP address. The other thing is you'll need some sort of IP routing in place, either static, which it looks like I've got here, or some interface so you can actually reach the remote IP address. OSPF, just a few little things that you could tick for in the exam questions. Administrative distance there. The other weird thing is they ask you the name of the algorithm. I don't know why they do that, so I think it's a silly question, but if you could pronounce this DHCP, I think, it uses the SPF algorithm. They'll try and trip you up between that and the EIGRP algorithm names. The router ID is usually the highest IP address on the router. The loopback address is used as ID if there's a loopback interface present, which is one way of you manually setting the router ID. The backbone area is area 0, and all non-backbone areas must be connected to area 0 unless you end up configuring tunneling, which I don't think is covered in the syllabus. All non-backbone areas must connect directly to area 0, as I've said. These are your possible area numbers. Area 0 is your backbone. Multicast on 224.0.0.5, so make a note of that address. It uses 10 to the power of 8. I couldn't use superscript for some reason. 10 to the power of 8 times your bandwidth. This is your OSPF cost calculation. A few good things about it. OSPF offers faster convergence. You have a hierarchical design with multiple areas, which you will consider during your design phase. There's tables that will be installed for OSPF, your neighbor, your OSPF database, and your routing table. Just a few terms. LSAs, I think it's in the syllabus, but you probably don't need to know much about it, so I've taken out a lot of this information. They're used to organize the topology, and it's a data structure. Your link state database is your collection of LSAs which are known to the router. Your ABR is an area border router. I'm not sure why I didn't put the full name. So it's a router that sits at the border of multiple OSPF areas. Your router ID I've mentioned, so you're normally the highest IP address of your physical or loopback interface if present. This is a simple configuration, router OSPF. This is locally significant. So in case they try and catch you out and say that it all needs to be the same over your network, this is just for the database number. Then we'll have our network, and then we have our wildcard mask, and then we need to specify which area that this network is in. We can also configure it under an interface, which you have to for IPv6 OSPF. Alright, various network types, your broadcast multi-access, your point-to-point, point-to-multipoint thing. Just read up on that and just look at the different times you'll need a designated router and a BDR, which you just got down here. Sometimes you'll need these and sometimes they don't, depending on which network you're using. The designated router receives all of the updates and LSAs. It's on the basis of a high priority number. By default, it's 1. Your OSPF relationship, I've put down the various states that the interface can be in while it's trying to establish a relationship. It's probably worth you noting all of these states in case you get a multiple choice question. Your LSAs, link state advertisements, there are 7 types. I think what, if anything, you'll just need to know the type, number, and the name. So type 2 is network, type 3 is summary, and so on. If you're asked anything, this is more of a CCNP level topic. If you want to check your LSAs, then show IP OSPF database. Your OSPF interface costs, again, this is a multiple choice question. You'll have a list, and or it could be a drag and drop, and it will say like your OSPF cost, drag it to the correct interface type, and you will drag it to whichever the corresponding type is, and then the lowest is 1. So even if it's ATM, fast Ethernet, or gigabit Ethernet, it all still gets the same value. OSPF3 acts similar to OSPF2, so you've got the same sort of configuration commands. But we have a neighbor discovery process similar. The only thing to mention is, I mentioned before there are 2 ways for OSPF to configure, which is the network command, and then you can actually go to the interface. For OSPF version 3, it's interface only. So I'll go interface, whatever the name is. I've obviously got my IPv6 address in here, and here's where I do my OSPF configuration. IPv6, I know that sounds obvious, but people try and configure IP OSPF1. That configures version 2 of OSPF, not version 3. OSPF, the process ID, and then what area this interface is in. Later on, you'll configure your globally IPv6 router OSPF. You need to have your 32-bit router ID. It's not IPv6 router ID for IPv6 OSPF, so don't get caught out. Here's your LSA types. Don't think you'll get asked anything about that, but I've put the slide in just in case. A few differences. Your type 3 LSA is different. Your neighbours don't have to be in the same IPv6 subnet, whereas for IPv4 they should be. New LSA types, which I mentioned. Some troubleshooting. Check your neighbour adjacencies. Check your timers. This is the same for OSPF. Check for your OSPF area. The network type. Check if your neighbourship state is full. Check if link state advertisements have been exchanged. A few commands you can use. Show IP protocols is your go-to. Then you can check your interface, your neighbor, your OSPF database, and then you can debug adjacencies. Obviously, not on a live network. EIGRP, the tick boxes for the exam, it uses IP protocol in 88, especially handy if you're doing Wireshark packet captures. Classless, so it recognizes VLSM. It's actually a hybrid. It's an advanced distance vector protocol, but it uses some link state services. Multicast on 224, which you recognize as a multicast address, 0010. Now it uses the concept of feasible successors to determine alternate routes to other networks. The feasible successor is a backup route based upon the EIGRP topology table. It actually does triggered updates if there's a change to a route. It's Cisco proprietary, however, just note that they've released it as an open standard, so just check what the exam question asks you. Maximum hop count, the limit is 100 by default. You can actually extend it if you so wish. Please do take expert advice if you do this, and that's to 255. You can support equal and unequal load cost balancing, so you can have a high speed link and a slower speed link, and it would share the traffic. This is just an estimate, by the way, depending on how you configure it and what the defaults are. It would say 90% over the super fast and maybe 10% or so over the slower link. Just depends. You've got your possible 5 values for your EIGRP metric. However, please note that by default, and you'll see this when you issue the show IP protocols command, by default only K1 and K3 are turned on. Turn on the others only after you've spoken to Cisco TAC. So K1 bandwidth, K3 delay are both used by default in the calculation. The values must match between 2 routers, and the final metric I've already mentioned. It uses something called the diffusing update algorithm, or DUAL. The feasible distance is the total distance from the source to the destination. The advertised distance is the distance told by the next top router. So if you've got your routers here, this one will be sending a distance of whatever, and that will be called the advertised distance. This will then add, so if that's 1 and this is 1, it will send the advertised distance as 2, for example, to the next router. The successor is the best route or shortest path to the destination. Feasible successor is the second best, and this will be inserted into one of the EIGRP tables, the topology table. So check your study guide and hopefully it'll go into more information, but you've got router 1 here and it's trying to establish how to get to router 4. And these are the speeds of the links. You've got various speed links for whatever reason on your topology. So the feasible distance, the advertised distance here. So router 4 is advertising 3 to router 2. And obviously the link between router 2 and router 1, the cost is 2. So it would have put 5 is the feasible distance, and the advertised distance it's receiving from router 2 is coming between 2 and 4, which is your 3. So the feasible successor is added here. The advertised distance coming from R4, you've got your 9 in total here. Let me just put this here. This route here is installed as the successor. This is installed as the feasible successor. The reason is the 5 is less than the advertised distance here. So if this distance is less than, it will be installed into the top topology table. If the advertised distance is more than the feasible distance, it will be discarded, because its chances are it's actually coming through this router also. So this is going to prevent a loop. So best if you read up more in your study guides, and hopefully they'll explain that, because you could get a table like this in the exam and they will ask you which is going to be your feasible distance, your advertised distance, your successor route and your feasible successor. The configuration is pretty simple. Your router, your EIGRP, your autonomous system. This has to match on all routers. OSPF it doesn't, but this does have to match. Your network number, you don't need a wildcard mask or a subnet mask here. The no auto summary is on by default in iOS 15 and any iOS, which is 15.0 and above. I've already mentioned the tables. It's got a neighbor table, a topology table, and then a routing table. Troubleshooting, you can go from the bottom to the top or top to bottom. Obviously, clock rates on your DT interfaces, or the interface is shut down. Wrong encapsulation type needs to match. Wrong IP address or subnet mask, and then often the wrong AS number or the wrong network is advertised. For version 6, it works in the same way. Its metric cost is also calculated in the same way. Successor and feasible successors, the same concept of equal and unequal load balancing. The difference you'll see, obviously you've got your IPv6 configuration, you've got your IPv6 address, but here IPv6, this is for your addressing also. Your configuration under the interface, IPv6 EIGRP1, and then your global. You've created your IPv6 router EIGRP1 and your 32-bit router IT. But you can see I've actually done my configuration under the interface to put this network or IP address into the autonomous system number 1. WANS is in the syllabus. It's kind of there in a general sense really. So I'll just cover a few basics. You've got point-to-point or lease lines. These work on serial links. Circuit switching transmits data with the help of a telephone line, such as your public switch telephone network, ISDN, DSL, etc. Packet switching is similar to a lease line, but it's shared with other people. An example is frame relay. Now, frame relay used to be in the syllabus, it's not anymore, but they do allude to it with the certain things they put in the syllabus, such as permanent virtual circuits and split horizon and things like that. So just be careful. A few things about your protocols for layer 2. PPP, the thing they might ask you is if you're connecting to a non-Cisco device, what would you use? And the answer is almost always PPP, because it works with any vendor. The command is encapsulation PPP. You can also, if you wish, add authentication. CHAP or PAP. PAP is clear text, PAP is a three-way hash. HDLC is the default at the moment on Cisco serial interfaces. Frame relay I've mentioned. They do allude to it, but I don't think you get asked a specific configuration question. VCs, virtual circuits, are used with frame relays. I think this is mentioned in the syllabus as well. Permanent virtual circuit is connected all the time. Switch virtual circuit is set up on demand. DLCI is another frame relay concept. It's basically a number. It's a layer 2 ID number, so the information can be sent along the correct circuit. I'm scooting through this because I don't think this would come up anymore. In fact, I'll scoot through that. IPv6. To enable IPv6, the command is IPv6 unicast routing. It's not enabled by default, but they could change it in a later iOS. In fact, I'm sure they will. Here's an example. So I've enabled IPv6. I've gone to my interface. I've gone IPv6 address, and then I've added an IPv6 address to the interface. Here's an example of a static route, IPv6 route. To get to this network, go to this address. IPv6, there's a ping command here. I have to try this out. Actually, I think I should have added the CIDR there on the end of that. Troubleshooting, here's a few commands. When you're doing your labs, please issue these commands on your router to check the output and see what you get. Network management, SNMP is definitely in the exam. The main thing is you need to know about managers and agents, but the main question seems to be revolving around what new features are in version 3. They are 1. Message integrity, 2. Authentication, and 3. Encryption. You have a database called MIBS for SNMP, all versions. Syslog, the Syslog server sends messages and provides display outputs. Syslog, I think, is in the ICND1 and ICND2 syllabus. NetFlow is mentioned also. It basically gives you statistics on IP packets. Some router elements. You need to know what DRAM does, what ROM is, what flash does, non-volatile RAM, and your config register. Okay, ROM's one of the major components of the router. It has 4 programs or parts to it. Your power on self-test, the bootstrap. This helps find and load. I think they should say iOS, I'll have to check, and the device config file. You have a mini iOS and then ROM monitor mode. This is the safe mode of the router. This is the booting process, so you could have a drag and a drop for the exam. So this could be at number 3, 2, 4, 1, whatever, and you would drag them into the correct order. Config register, so 16-bit hex value. I think the only thing you need to know is that the default is 2102. I'll just come to what I want to tell you in a moment. Alright, so 2142 basically tells the router to bypass the non-volatile RAM. This will go to setup mode, so you can recover lost passwords, or if you've bought a router second hand. So this is not the default. You need to change the router config register, and then when you've finished, if you want the router to boot, remember what's in the configuration file, and the startup configuration file, you would have this present instead. Password recovery, ROM and mode is used to recover passwords. It gets pretty tricky on switches, so hopefully they won't ask you about that, because you have to boot, and depending on the model you have to have certain buttons pressed in as you boot, and even then it's still difficult to do recoveries. With the new router, the external flash will be removed and the router's turned off. On booting, the router is enabled to load the iOS from flash, so the router enters Roman mode. The best thing to do is issue the password recovery name on Google and then your model. So whatever your switcher router is, you issue password recovery and then you add the model name and you'll find the documentation. You set the configuration register to ignore the startup files which has got the passwords in, and you do that by making it 2142. On boot up the router with flash, it will now reach enable mode without a password, and then you can issue the copy startup config to running config and then change your passwords. Just a few commands here that is worth remembering, and also this will work because it knows what you mean, but the correct output is show flash and then colon. Show version, important to know, and try it on your device what it actually shows you: your uptime, your iOS version, config register SHARI value, memory stats, time of last loading. It'll also show you the reason for the last reboot as well. The license boot module, you need to know that command. Show license feature. You can try all these on Packet Tracer. QoS is now in the exam, only a basic overview. It's basically to manage scarce bandwidths. You've got it. In fact, it's an even better diagram here. You've got normal traffic, which will have normal priority. Entertainment traffic, which you could have as a high or a lower priority or normal, and critical traffic. So this would be in terms of can it deal with any delays or drops, and probably not. So voice traffic especially, and maybe for video, although that tolerates delays better. But any drops on voice will normally mean your call drops. If you want to see if you've got it enabled and what the default mode is, it's show MLS QoS, and it will say if it's enabled or disabled. Then you can go config T and then configure whatever QoS you want. And then here I've enabled QoS, and you can see QoS is enabled. A few models you need to know about: best effort, integrated service, or differentiated services. Traffic classification differentiates one stream of traffic for another, and then it knows which stream to give priority to. Policing is used to limit traffic to a prescribed rate. So if it's trying to get up here, your policing will limit it to whatever level that you've set, and then it will drop down again. Marking involves setting QoS bits to include layer 2 or layer 3 heading, so it will put a mark in whichever the particular part of the packet or frame is. Your congestion management tools are queuing, dropping, or scheduling. I'm not sure if I give you a description of these actually. No, I don't, so look that up. Your IPv6 access list, you can't use numbered. So that's a no-no. So it can be a named, standard, or extended. The only thing is you can't use the same name as the IPv4 named. So if you've got an IPv4 access list named hello, for IPv6 you would have to give it another name, like hello2. I know it's a silly example, but you just can't. So IPv6 access list, I'll give it a name, then you'll drop into this output here. I will, whatever you want to do, permit, deny. I'll deny this network to any other network. I'm just playing with commands here, by the way. Permit, question mark, what can I permit or deny? This is quite limited because it's Packet Tracer by the looks of it. I'll permit IPv6 from anywhere to anywhere. The important thing you need to know is when you're applying it to your interface, it's not access group. For some weird reason, it's IPv6, traffic-filter, name, and then in or out. SLAs also in the exam now, even though it's mainly a CCNP topic. It's your service level agreement. It measures and monitors network performance. Things that it can measure are example as jitter, latency, which is your delay, and any packet loss, and it can give you a report. It's comprised of a source, which is your router or switch, and a target, which is any network device, and obviously including router or switches. You can categorize them into these following 5 areas, so just make a note. And then the iOS, just be careful because the command changed from iOS 12 dot whatever to 15. Why they did it, I don't know, because it's certainly caused me a headache, and I'm sure it has most other people, especially if you've got multiple iOS versions on your network. So IP SLA and then the operation number, hit the question mark. It used to be IP SLA responder or IP SLA monitor, so that's caused a lot of confusion. Span, switch port analyzer, it allows you to capture packets. So this is basically sniffing packets on your network. Wireshark's probably the main program for this. Local span is the only version in the syllabus, just so you know. There's others though, there's remote span, encapsulated RSpan, etc. These will be CCNP, probably switch topics. These are the ones, but local span is covered in the syllabus. Here's the sample configuration. I'm not sure, check the syllabus. I'm not sure if you just need to know theory or you're asked to configure it. I've got a feeling it's just know the theory. AAA, authentication, this validates the identity of who the user is. Authorization determines what the particular user can do. Accounting is used for audit trails. So authentication, authorization, and accounting is what AAA stands for. Standard authentication models, if you want to enable it, you just go into global config mode, AAA space, new dash model. Your authentication methods include Radius, TACAX, and Kerberos. You'll need to know a little bit about all of these for the exam because they're in the syllabus. Just a few differences. I think you just need to make a note of these because this is your typical type of exam question. It'll be a drag and drop or multiple choice as to which applies to which. Alright, BGP, brand new topic, but you don't need a huge amount of knowledge. It's used to exchange NLRI, network layer reachability information. So basically it's concerned with, I've only put one router in, but each administrative system. This is what it's interested in. And you can actually see the NRLI information here, and it's giving you the path to get from wherever it needs to be to wherever it needs to go to. The important thing to remember is your NLRI is comprised of 2 things. Your prefix and your length. So here's your prefix here and here's your length here. So just bear that in mind for the exam. They could have other things like what's the AAS or what's whatever, but none of this is applicable to that particular part of the packet. The other thing is it's reliable. It uses TCP port 179. It tracks AS numbers rather than router hops. So this is why your ISPs will be using it more than your small business. Alright, so we've come to the end. Thanks for watching. I hope it helps. I'll get these slides available once I've done a few tweaks to them. Go to the howtonetwork.com free training link if you want to get the emails. Otherwise, if you hit the bell, I'll send you updates as and when I do it. Drop a comment and I'll be checking every few days. Thanks for listening.